Mpirical provide compelling, interactive learning across a range of delivery options. Live on site, live online, or online anytime, we have a training course that is ideal for you. For a no-obligations chat about your training requirements, contact us at mpirical.com.
Before a station can actually start to transmit information across the wireless medium, it must first find a suitable Wi-Fi network. And in this video, we're going to explain how this takes place. Therefore, we're going to begin by explaining the concept of scanning for Wi-Fi. This is one of the methodologies by which the station can build up a picture about the available Wi-Fi networks. We'll then move on and look at the probing for Wi-Fi methodology. This is typically the one that most phones, tablets and computers will use. And finally, we're going to turn our attention for tracking Wi-Fi devices. It's using the probing for Wi-Fi method to actually build up a picture about the location of a Wi-Fi device within a specified environment. So to begin with then, let's have a look at how the stations will actually find a Wi-Fi network. As we said, there are two real methods of doing this. A passive method, by which the stations will sit and listen and look out for beacon messages which are broadcast from all of the access points. Here in our passive method, the stations will not transmit any information. They will simply listen to and decode the beacon messages. The second method, which is active, actually requires the stations to transmit information. And here we can see they will transmit probe request messages out on the various Wi-Fi channels and await the access points to return the. However, both methods will enable our stations to build up a picture of the available Wi-Fi networks within their vicinity. So then, to begin with, let's have a look at what happens in the passive method. Here we can see we will be scanning for Wi-Fi. Well, our access points will be transmitting beacon messages on their suitable or the particular channel to which they've been set. And our station will simply scan across the various channels, listening out to these beacon messages. So, what does the beacon message actually contain? Well, it will contain a timestamp. This is simply a period of network time, enabling our stations to synchronize onto the various beacon messages. It'll also include a beacon interval. This will tell the station how often the beacon messages are going to be broadcast. Typically, this is set to 100 milliseconds. So normally we would expect 10 beacon messages every second. We also contain the SSID, the service set identity. This is the name that the administrator gives to this particular access point. For example, Fred's Network or Coffee to Go. We may also contain the country. Again, as the name would suggest, it will indicate in which country this access point is operating, which may have effect on maximum power levels, etc., etc. We've also got the supported rates. In other words, what are the potential data rates that this network or this access point is capable of supporting, be that operating at 802.11b or up to the higher throughput rates supported by 802.11n and AC. We may also include quality of service information, but this will only be included in those access points which are supporting quality of service methodologies. And finally, we have the traffic indication map, or the TIM. This is used by stations in power save mode. It simply indicates to these stations that the access point is holding data on their behalf, ready for when they wake up and to be able to receive this information. So we can see in this methodology that our stations monitoring the beacon messages on the various Wi-Fi channels will be able to build up a list not only of the various access points in their vicinity, but also the capabilities of these particular Wi-Fi networks. The second method then, the active method, is typically one that's employed by our mobile phones, by our tablets and our Wi-Fi enabled laptops. And here we can see they will use a combination of probe request and probe response messages to build up a picture of the available Wi-Fi. So again, let us see how this actually takes place. Well, here then the station will fire out a probe request message. This will typically be broadcast out on a particular channel. And the station will wait here for those access points on that channel to return a probe response. It will then typically move on to the next channel and repeat the process. therefore building up the picture across all of the available Wi-Fi channels. Now inside the probe request, the station may include the SSID value. In other words, probing for a specific network. However, typically this will be set to null, triggering all access points to respond. In addition, the station may also include its supported rates, the sort of data rates that the station is able to support, be that 802.11b through to our 802.11ac physical layers. Now the access point will return the probe response message. Now to all intents and purposes, this is the same as the beacon message, containing fundamentally the same information, that being the timestamp, also including the beacon interval and the SSID, the name of this particular network. It may also include the country of operation, but it will include the supported rates. Again, the capabilities of this access point in terms of the different physical layers that they may be supporting. And finally, it may also include quality of service information, assuming this access point is supporting the transmission of real-time applications, voice and video-based data. However, the probe response will not include the traffic indication map. Remember, this was used by stations in power save mode. So by detecting these probe response from the various access points, we can see the station will begin to build up a picture of the capabilities of Wi-Fi within its vicinity. Here we can see the next access point will now seize the medium on this particular channel, and it too will return its probe response message. So therefore, depending on the particular operating system being used, be that Android, Windows or iOS, we can see here a list of potential Wi-Fi networks which were detected using the probe request and probe response method. Typically now it's down to the user to select one of these access points to join, to connect to, or potentially, if they previously connected to this access point before, our connection manager inside the device may automatically move on to the next process of joining the Wi-Fi network. Okay, the final thing we want to look at then in this video is how this probe request and response can be used to actually track the location of a particular Wi-Fi device. So here, remember, by sending out the probe request messages, this information can be picked up by multiple access points. Now, the probe request message is based on a standard Wi-Fi frame and therefore will contain the standard addressing information. Here we can see it will include the source address of this particular station, the MAC address of our Wi-Fi device. It will also contain the destination address. But in this situation, we'll be using the standard broadcast IEEE MAC address. And finally, as this is destined for the actual access point itself, the receiver address will also be set to broadcast. We may also contain the SSID. Remember, this was the name of the network that we were wishing, to gain access to. But typically, this is set to null, triggering all available access points to respond. Now, by sending this information up to the access points, it's possible that the access points can maintain the information about the MAC address of this station. This information is clearly indicating that this particular station has been within the radio vicinity of this access point. Bearing in mind that the typical coverage areas used by Wi-Fi inside a building is approximately 30 meters or slightly greater outside, it will give you an indication certainly of the location of this particular station. Furthermore, by also building in or measuring the signal level at the various access points, we can actually now start to become a little tighter in locating the device. Clearly, the access point recording a higher signal level will assume that the station is closer to it than an access point measuring a lower signal level. So a combination of the received signal level and the MAC address of our station clearly enables us to start to track the location of the mobile. Okay, so how is that used in today's commercial environment? Well, it's not uncommon now, things like shopping centres or shopping malls, to employ this Wi-Fi tracking. Clearly, they have Wi-Fi enabled throughout the vicinity as a service to the customers, providing them with connectivity out onto the internet. So if we focus into a particular area here, it wouldn't be uncommon to see a series of access points distributed across the shopping centre or shopping mall, providing with coverage. Therefore, as a station enters and continues to send the probe request messages, these could be detected as it moves around from access point to access point, again recording the MAC address of this particular station. Therefore, by collating all this information through a central processor, we could then detect a particular route by which this user has actually moved. Furthermore, by measuring the time at which the probe request arrived at the access point, we can actually now work out not only where the particular station moved, but how long they sat in a particular area. Again, this could be incredibly important marketing information, again detecting how long a particular station stayed in front of a shop or stayed within a particular environment. So there we have it, the methodology employed by our stations as they try and find a suitable Wi-Fi network. To begin with then, we looked at the passive method, which we used the combination of beacon messages broadcast from the various access points, enabling our station to build up a picture of the available Wi-Fi. However, the more common approach used by stations today is the active method, where the stations will transmit a probe request and await probe responses from the various access points. And finally, we had a look at how this information could be used to track Wi-Fi stations as they move around a vicinity, using a combination of the probe request messages, the MAC address of the station, and finally potentially the signal level, giving us a tighter indication of the location of this station.
Need to know more? Why not visit our store, where you can choose from over 200 hours of video-based training. Alternatively, you can contact us to discuss any specific training requirements you may have.